Welcome back. Today we're going to be graphing this function here, which is e to the power x minus 3x minus 4. Now, the thing is, e represents an irrational number, and so we're not going to be able to get everything exactly to the very last decimal place, but we do need to make sure that the key components of a graph are in the correct places. So here's how we do that. The key components would be the zeros, the y-intercept, and then if there's any turning points, so if there's any local minimums or local maximums, things like that. And also in this case, we're being asked just to draw it within the certain domain, just from -4 to 3. And so it is probably a good idea if we get the endpoints approximately right as well. So to find the x-intercepts, or the zeros, we're going to sub in 0 for f of x, and then figure out which approximate values we would have here, right? So in order to do that, I'm going to, we're going to add 3x and add 4 to both sides. So e to the power x is equal to 3x minus 4. And then we can ln both sides. So let's do that. Ln e to the x is equal to ln 3x minus 4. So therefore, x is equal to ln 3x minus 4. So in this case, what are our approximate values? What values for which, would this work approximately? Well, this is going to work somewhere between -1 and -2. So I'm going to put a point there. And I'm also going to put a point between 2 and 3 right there. All right, for the next part, let's talk about where might the turning point be and also where the y-intercept would be. So for the y-intercept, we just need to plug in f of 0 and find out what that is. That would be e to the power 0 minus 3 times 0 minus 4. That is going to be 1 minus 0 minus 4, which is -3. So therefore, -3 is where I'll put that value right there. Then we need to figure out the turning point. So to figure out the turning point and where that would be, we need to take the first derivative and set it to 0 to find out if there's any local mins or maxes that are in this area. So if we take the derivative, we end up with e to the power x minus 3. So, and then we're going to set the derivative to 0 to find the turning points. So we basically need to figure out approximately where would e to the power x equal to 3. Well, to do that, we can ln both sides and get ln of 3. Now, ln of 3 is a number that is between 1 and 2, approximately there. And then, yeah, that's where it's going to be at. And then we're going to need to plug in the value we found for ln 3 back into the original to find the y value. So we need to figure out f of ln 3 in order to get that value where we want it. Okay, so ln 3, that is approximately 1.09. So I'm just going to say that's about 1.1 for x. And then f of ln 3, that's going to be e to the power of ln 3 minus 3 times ln 3 minus 4. So e to the power of ln 3, well, the thing is e and ln are inverses. And so they are just going to cancel, and that's just going to be 3 minus 3 ln 3. That's going to be approximately minus 3.3 and minus 4. So that's about minus 4.3. And keep in mind, it's okay if you don't get the exact value. We just want to make sure you have the approximately correct value. So basically, the approximately correct value for that turning point is going to be at 1.1 for x and at negative 4.34y. So around there approximately is going to be good. All right, now we have the turning points here that we need to do, or sorry, not turning points, we just did the turning point. We have the endpoints. So for endpoints, we're going to find f of 4, or sorry, f of negative 4, and f of positive 3 to find out our latest points. So that's going to be e to the power negative 4 minus 3 times negative 4 minus 4. So e to the power of negative 4 is 0.02, and then plus 12 minus 4. So that's going to be 8.02. So basically right around 8 for the for that value. So negative 4 and then approximately 8. So right around there. And then for the other one, f of 3, that's going to be e cubed minus 3 times 3 minus 4. Now, e cubed is about 20. And then that's minus 9 minus 4 is going to give us approximately 7, right? I guess closer to 7.1 because this was about, should have really been about 20.1. So 3 comma 7.1 is about right. And now I'm just going to draw a nice smooth curve as best I can through this. Keep in mind though, if your curve is a little bit off, that's okay. The main thing that we care about when it comes to this curve is that the key points, so the zeros, the x-intercept, the turning point, the endpoint, are in approximately the correct spot. That is the main thing to keep in mind.